In 1981, Cadillac told the world they'd built the smartest engine ever made, a V8 that could think for itself, shutting down cylinders it didn't need and firing them back up when it did. 3 engines in one, they said. The computer controlling it could process 300,000 operations per second. It couldn't process a left turn out of a parking lot. They made this engine standard, not optional, standard. On every gasoline-powered Cadillac that year, every DeVille, every Fleetwood, every Eldorado, every one. So here's the setup. It's the late 1970s, and the American auto industry is in a state of controlled panic. 2 oil crises in the span of 6 years have fundamentally shaken the country's relationship with gasoline. The OPEC embargo of 1973 was bad enough. People waited in line for hours just to fill their tanks. But then came the 1979 crisis, triggered by the Iranian Revolution, and it was even worse. Gas prices doubled almost overnight. Lines wrapped around city blocks. In some states, you could only buy gas on certain days depending on whether your license plate ended in an odd or even number. And suddenly, Americans who had spent 3 decades buying the biggest, heaviest, thirstiest cars on the planet started asking an uncomfortable question. How many miles per gallon does this thing actually get? For most car companies, this was a painful but manageable headache. You downsize, you add a 4-cylinder option, you put a smaller car in the lineup, and move on. But for Cadillac, it was existential. Cadillac didn't make practical cars. Cadillac made statements. The Fleetwood Brougham was 221 inches long. That's over 18 feet of chrome, leather, and American optimism. These things had trunks you could camp in, interiors that felt like upholstered living rooms, and under those long, sculpted hoods sat massive V8 engines that consumed gasoline with the enthusiasm of a teenager at an open bar. For decades, nobody cared. Gas was cheap. Cars were big. Cadillac was king. But the federal government was done playing along. The corporate average fuel economy standards, known as CAFE, had been established in 1975, and the targets were ratcheting tighter every model year. If your fleet's average fuel economy didn't hit the number, you paid penalties, significant penalties, multiplied by every car you sold. And on top of that, the Energy Tax Act of 1978 created something called the Gas Guzzler Tax. Starting with 1980 models, any new passenger car that fell below the minimum fuel economy threshold got slapped with an additional tax at the point of sale. The tax started at $1,000 and could go much higher depending on how badly the car missed the target. For Cadillac, whose entire lineup consisted of full-size luxury sedans and coupes, this was a direct assault on their business model. The obvious answer was smaller engines, and Cadillac had already started down that path. Their old 7-liter 472 cubic inch V8 had been downsized to a 6-liter 368 cubic inch V8, designated the L61. They'd added throttle-body fuel injection to the Eldorado and Seville, which was relatively cutting-edge for 1980. The rear-wheel drive models still used a Rochester Quadrajet 4-barrel carburetor, but even with these changes, the numbers weren't enough. The DeVille was getting maybe 15 miles per gallon in the city. The CAFE targets were heading toward 27.5. Cadillac was staring down a canyon between where they were and where they needed to be. But here's the problem with the obvious answer. Cadillac's customers would not have tolerated a small engine. These were people paying upward of $15,000 for a car in 1981. Adjusted for inflation, that's pushing $50,000 in today's money. A base DeVille started around $14,782. An Eldorado could top $20,000 easily. These buyers expected power. They expected smoothness. They expected the effortless, vault-like experience that had defined the brand for decades. Sticking a wheezy 4-cylinder or even a modest 6 into a 4,000-pound Fleetwood would have been an insult to every customer who walked through the dealership doors. Cadillac knew this. Their competitors at Lincoln and Mercedes knew this. The whole industry knew this. So Cadillac's engineers had a different idea, a clever one. What if you didn't need all 8 cylinders all the time? Think about how people actually drive. Most of the time, you're not demanding full power. You're cruising on the highway at a steady 55 or 60 miles per hour. You're coasting through suburban neighborhoods at 30. You're idling at traffic lights. In all of those situations, a 6-liter V8 is massively overpowered for what you're asking it to do. You're burning fuel through 8 cylinders when you might only need 4. What if the engine could figure out how much power was actually needed and shut down the cylinders it didn't need, then fire them back up instantly when you actually asked for power? The concept wasn't new, not by a long shot. The idea of cylinder deactivation had been floating around since the early 1900s. Those old hit-and-miss engines that powered cotton gins and factories across rural America used a crude version of the same principle. A centrifugal governor with weighted balls would spin faster as the engine accelerated, and when it reached a certain speed, it would mechanically hold the exhaust valve open so the cylinder wouldn't fire on the next stroke. The engine would coast or miss until RPM dropped and the governor released the valve. It was cylinder deactivation in its most primitive form. The concept had even been tested on multi-cylinder aircraft engines during World War II with some success. But no one had ever mass-produced it in a passenger car. Cadillac decided they would be the first. They partnered with the Eaton Corporation, a major automotive supplier based in Cleveland, to develop the deactivation hardware. GM engineer Chris Meagher worked closely with Eaton's vehicle division to create what became the L62 engine. The foundation was the same 6-liter, 368 cubic inch block from the L61. Same bore, same stroke, same bottom end, drawn from a family of Cadillac big block engines that traced its lineage through the 425, the 472, and all the way back to the late 1960s. Proven, battle-tested, reliable hardware that had powered hundreds of thousands of Cadillacs without complaint. But above that proven bottom end, everything changed. The cylinder heads were completely redesigned. 4 of the engine's 8 cylinders received solenoid-operated rocker arm assemblies based on Eaton's 1975 patents. Ford had actually experimented with the same patents earlier, but they discovered the transitions were too difficult to manage with mechanical controls and shelved the project. Cadillac thought digital controls would solve the problem. Tall, new rocker covers housed the solenoids and their associated wiring harnesses. When energized, each solenoid would lock the rocker arm at its fulcrum point, disconnecting it from the pushrod below. With the rocker arm locked, the intake and exhaust valves on that cylinder stayed closed. The piston still traveled up and down in the bore, still driven by the crankshaft, but no air-fuel mixture could enter and no exhaust could leave. The air trapped in the sealed cylinder would compress and decompress on each stroke, acting as a pneumatic spring, a cushion, Cadillac called it. The system deactivated cylinders in opposite pairs to maintain engine balance, starting with cylinders 1 and 4. Under light loads, it would shut down 2 cylinders, turning the V8 into what was effectively a 4.5-liter V6. Under even lighter loads, 2 more would shut down, creating a 3-liter V4. When you demanded power by opening the throttle, all 8 cylinders would come back online, 3 engines in 1. That was the pitch. Cadillac trademarked the marketing name modulated displacement. Controlling all of this was the computer command module. This was essentially one of the very first engine control units ever installed in a mass-production automobile. It managed not just the cylinder deactivation, but also the spark timing and the throttle-body fuel injection. It processed inputs from sensors monitoring engine speed, road speed, manifold absolute pressure, throttle position, coolant temperature, oxygen content in the exhaust, and more. Cadillac's advertising proudly announced that the computer command module could handle 300,000 operations per second. The system also included what was, for the time, an advanced onboard diagnostics program. You could display engine trouble codes right on the climate control panel. In 1981, this was genuinely futuristic stuff, and Cadillac didn't hedge their bets. They didn't offer this as an option package or test it on one model. They made the V8-6-4 standard equipment across the entire 1981 gasoline lineup. The DeVille, the Fleetwood Brougham, the Eldorado, all of them. The only model that escaped was the Seville, which came standard with an Oldsmobile-built 5.7-liter diesel V8. That engine was its own spectacular disaster, but that's a story for another day. In fact, 1981 might have been the single worst year in GM powertrain history. They launched the V8-6-4, which couldn't decide how many cylinders to run. They had the Oldsmobile diesel, which couldn't decide whether to run at all. And Mercedes-Benz, perhaps sensing an opportunity, chose that exact same year to launch their turbo diesel 5-cylinder in the 300D, establishing the reputation for German engineering quality that endures to this day. The timing was almost poetic. GM was handing them the market on a silver platter. They even installed a dashboard gauge called the MPG Sentinel, a digital display that showed the driver, in real time, how many cylinders were currently active, or alternatively, the car's instantaneous fuel consumption in miles per gallon. It was meant to be a technology showcase. Look at your Cadillac thinking. Look at how smart it is. As it turned out, the gauge was entirely unnecessary. Drivers didn't need a display to know the system was active. They could feel it in their spine. Cadillac's chief engineer, Robert Templin, was the public face of the V8-6-4 campaign. He made some remarkable claims. He told the press the system could deliver 4 to 5 additional miles per gallon on the highway. He claimed it was more valuable than adding an overdrive gear to the transmission. He called the throttle-body injection system the greatest advancement since canned beer. Those were his actual words, canned beer. The company published a 12-page pocket brochure for salesmen, urging customers to sit behind the wheel and experience what a remarkable advancement it truly was. The press got early production examples, and the initial reviews were cautiously positive. In controlled conditions, with GM engineers hovering nearby and the cars freshly prepped, the system seemed to work reasonably well. The computer command module could process 300,000 operations per second. The transitions appeared smooth enough during short demonstration drives. Motor Trend and Car and Driver noted the technology with interest. This was, after all, genuinely unprecedented for a production car. The computer command module was doing things no automotive computer had done before, and on a test track, at steady speeds, with predictable loads, it could do them. Everything seemed promising. Then real customers started driving them home, in traffic, up hills, in winter, with the air conditioning on, in stop and go, in the real world. Everything went wrong, quickly. Almost immediately, complaints flooded into dealerships nationwide. The engine hesitated during acceleration. It bucked and surged at cruising speed. It stumbled during transitions between cylinder counts. In some cases, it stalled entirely. The smooth, invisible operation Cadillac had promised was, in reality, more like riding a horse that couldn't decide between trotting and galloping. Owners could feel every single transition in their seat. They could hear it in the engine note. The V8 would go quiet for a moment as cylinders dropped out, then lurch back to life when they reactivated. The engine would hunt between cylinder counts at certain speeds, going back and forth between 8 and 6 and 4 like an automatic transmission that couldn't find the right gear. Some speeds were dramatically worse than others. One limousine driver in the 90s reportedly kept a handwritten note taped to the dashboard listing 2 specific velocities to avoid, somewhere around 45 and 68 miles per hour, because the hunting at those speeds made the car virtually undrivable. He'd been dealing with the engine for years. He knew its moods. The car came equipped with that MPG Sentinel gauge on the dashboard, ready to show drivers exactly which mode the engine was running in. Cadillac thought this would be a point of pride. Instead, it became a source of anxiety. Owners would watch the gauge flicker between 8 and 6 and 4 and realize they were witnessing their engine have a nervous breakdown in real time. If you're enjoying this, hit subscribe. We cover stuff like this every week. All right, back to the engineering. Now let's talk about why this problem went deeper than software. The V8-6-4 had fundamental mechanical design flaws that no amount of computer chip updates could fix. Start with the fuel injection. The L62 used throttle-body injection with a single injector per cylinder bank. one injector feeding 4 cylinders on each side. There was no way to selectively cut fuel to individual cylinders. When the computer deactivated 2 or 4 cylinders by locking their valves closed, the injector kept spraying fuel into the intake manifold as if all cylinders on that bank were still firing. That excess fuel had nowhere to go. It pooled around the intake valves of the deactivated cylinders, sitting there, accumulating. Then, when those cylinders reactivated, all that accumulated fuel rushed in at once. The cylinders ran momentarily rich. The engine stumbled. Sometimes it belched. The fueling mismatch was baked into the design because throttle-body injection simply could not meter fuel to individual cylinders. It was a system-level failure. The deactivation hardware needed multi-point injection that wouldn't exist in Cadillacs for years. Then there was the EGR problem. The L62 used a positive back pressure exhaust gas recirculation valve. In a normal, steady-state V8, this works fine. Exhaust pressure acts on a diaphragm that regulates how much exhaust gas recirculates into the intake for emissions control. But when the engine dropped to 4 cylinders, it was producing roughly half the normal exhaust flow. Less exhaust meant less back pressure, which meant the EGR valve wasn't opening properly. The result was detonation, pinging. The active cylinders were now under higher individual load, running hotter, and they needed more EGR to control combustion temperatures, but they were getting less because the system was calibrated for full 8-cylinder operation. This caused engine knock and rough running that compounded the already miserable driving experience. Then there was the fundamental thermodynamic issue with the trapped air. Cadillac claimed the sealed cylinders acted as an air spring, cushioning the piston's movement, and technically they did. But those pistons were still compressing and decompressing that trapped air on every stroke. That takes energy. That's called pumping loss, and it's exactly the kind of parasitic inefficiency that cylinder deactivation was supposed to eliminate. A more elegant solution would have been to crack the exhaust valves slightly open, allowing the deactivated cylinders to breathe freely and minimize the energy wasted on compressing air that was going nowhere. But Eaton's solenoid system was binary, fully locked or fully unlocked. There was no in-between position. The engineering team apparently couldn't achieve partial valve opening with this hardware, so even the deactivated cylinders were still creating drag on the engine, just somewhat less drag than if they were fully firing. And then there were the genuinely dangerous failures. One man bought a brand new Cadillac and was driving home on the interstate at 80 miles per hour when the engine switched from 8 cylinders to 4 and died completely. No engine means no power steering and no power brakes on a 4,000-pound car traveling at highway speed. The owner was 63 years old. He described his life flashing before his eyes as he pressed the brake pedal with both feet and the car barely slowed. No other vehicles were close by. He survived by luck. He looked through the owner's manual, found the fuse that controlled the solenoids, pulled it, and traded the car in the very next morning. And here is the real insult. After all that suffering, the fuel economy improvement was effectively zero. The 1981 EPA Gas Mileage Guide rated the DeVille and Fleetwood Brougham with the V8-6-4 at 15 miles per gallon in the city. That was identical to the carbureted 1980 models without any cylinder deactivation whatsoever. The same number. All that complexity, all those customer complaints, all those warranty claims for no measurable improvement. Before launch, GM had claimed the system could boost overall fuel economy by up to 7%. In reality, nobody could find the savings. Templin's claims of 4 to 5 extra highway miles per gallon bordered on false advertising. GM tried to salvage the situation with software. They released 13 different updated PROM chips for the engine control module over the course of the model year. 13 separate attempts to reprogram their way out of what was fundamentally a hardware problem. Each update tweaked the parameters slightly, made the transitions a little slower here, a little faster there, adjusted the threshold for when cylinders would deactivate, changed the sensitivity to throttle input. None of it worked, not really. The problems were too deeply embedded in the architecture. You can't fix a slow computer by changing its instructions. You need a faster computer. And in 1981, faster computers that could fit under the hood of a car and survive heat, vibration, and Michigan winters simply did not exist at any price Cadillac could afford. So dealerships across the country performed the unofficial fix. Disconnect a single wire from the transmission's third-gear switch, or pull one specific fuse. That was the entire procedure. The engine would run as a conventional V8 permanently. No more hunting, no more surging, no more stalling at highway speed. Just a solid, smooth 6-liter V8 doing what 6-liter V8s had always done. Cadillac officially advised dealers to disable the system for customers experiencing problems, which was virtually everyone. Some mechanics simply cut a wire and forgot about it. Problem solved, in the most inelegant way possible. Cadillac also mailed letters to V8-6-4 owners with what they called an engine value protection plan, a 5-year, 50,000-mile warranty transferable to any number of subsequent owners. It was corporate damage control dressed up as customer care. The V8-6-4 lasted exactly 1 model year in passenger cars. Cadillac pulled it after 1981. The low-volume Fleetwood limousine kept the engine through 1984, and the carbureted version of the 368 continued in the commercial chassis for hearse and ambulance builders through that same year. But for the mainline Cadillacs that actual customers bought, it was done. And here's where the story gets genuinely tragic. Cadillac didn't retreat to the proven, reliable 368 V8 for 1982. The smart move, the safe move, would have been to go back to what worked. Put the carbureted 368 back in the DeVille, give customers a car they could trust, and rebuild confidence. Instead, Cadillac introduced the HT4100. HT stood for High Technology. It should have stood for Halfway There. This was a brand new aluminum block, 4.1-liter V8 that produced just 125 horsepower and 190 pound-feet of torque. For context, the V8-6-4 had made 140 horsepower and 265 pound-feet from 6 liters. The replacement engine was 40% smaller in displacement, noticeably weaker, and turned out to be spectacularly unreliable. Intake manifold gasket failures from the bimetallic aluminum to iron interface, aluminum oil pump failures, camshaft bearing displacement, block casting so weak that head bolts pulled the threads right out of the aluminum. By mid-1983, dealerships had rows of nearly new Cadillacs lined up waiting for warranty engine replacements at a rate nobody in the industry had ever seen before, or since. But here's the cruel irony. The V8-6-4 takes the blame for Cadillac's 80s meltdown in the popular imagination. People confuse the two engines to this day. The 1-year engine with the annoying computer problem gets lumped in with the 4-year engine that literally self-destructed. Salespeople and mechanics sometimes encourage the confusion. Blame the V8-6-4. It's an easier story than the truth. A fully loaded 1982 Cadillac with the HT4100 had roughly the same power-to-weight ratio as a diesel Chevette. 18-wheelers would pass them on hills. One owner described being overtaken by a rental moving truck while revving his engine to the red line in second gear. That was the HT4100 experience, not the V8-6-4. The collective damage was devastating and lasting. Cadillac had built its brand over decades on one simple promise: buy a Cadillac and it will be the finest car on the road, period, no questions. Your Cadillac will start every morning, ride like a cloud, and make you feel like you've arrived. The V8-6-4 cracked that promise. The HT4100 shattered it. Loyal customers who had traded in every 2 or 3 years for decades, families that had been buying Cadillacs since the Eisenhower administration, simply stopped coming back. They walked into Mercedes and BMW dealerships instead. The German brands, which had been a niche presence in America through the 70s, suddenly found themselves flooded with wealthy, disillusioned American buyers who just wanted a luxury car that functioned as advertised, one that started in the morning without drama, one that didn't try to stall at highway speed, one that delivered the experience its price tag promised. Cadillac's sales had topped 380,000 units in 1979. By the mid-80s, The bleeding was severe. The decline through that decade was relentless. The old-timers, the ones who remembered what a real Cadillac felt like, either held onto their pre-81 models or switched brands entirely. Some people specifically sought out late 70s Cadillacs and kept driving them because they knew those cars were better than anything the brand was selling new. The brand wouldn't fully recover its reputation for a generation. Some automotive historians credit the HT4100 era, that stretch from 82 to 85, with single-handedly establishing the German luxury car market in the United States. If you drive a German luxury sedan today, you can trace part of that tradition back to the moment Cadillac broke faith with its customers. But the core technology behind the V8-6-4 was correct. That's the part that makes this story sting. Cadillac wasn't wrong about cylinder deactivation. They were catastrophically, painfully early. In 1999, Mercedes-Benz introduced cylinder deactivation on the European market S-Class V8. In 2003, Chrysler launched the multi-displacement system on the Hemi. GM followed in 2005 with displacement on demand, later renamed active fuel management. Honda rolled out variable cylinder management, and every one of these systems worked smoothly, invisibly, exactly the way Cadillac had promised and utterly failed to deliver. The difference was computing power, and not just a little more computing power, orders of magnitude more. By the mid-2000s, engine control modules operated at processing speeds that made 300,000 operations per second look like counting on your fingers. Modern ECUs can monitor dozens of sensors thousands of times per second and execute adjustments within single-digit milliseconds. The transition between cylinder counts happens so quickly and smoothly that even automotive journalists struggle to detect it without instrumentation. Modern systems also use oil pressure to collapse hydraulic valve lifters rather than solenoid-actuated rocker arms, which is mechanically smoother, quieter, and eliminates the transition delay entirely. Multi-point and direct fuel injection means you can cut fuel to individual cylinders with surgical precision. No more fuel pooling around deactivated intake valves, and modern emission systems are designed from the ground up to handle variable cylinder operation, with electronically controlled EGR valves that adjust instantaneously to changing exhaust flow. By 2019, GM's dynamic fuel management system in the Chevrolet Silverado could run in 17 different cylinder patterns, not just 8, 6, and 4. 17 distinct combinations, from 2 active cylinders all the way to 8, constantly adjusting hundreds of times per second based on real-time driving conditions. The driver feels absolutely nothing, no surge, no stumble, no hunting, just smooth, consistent power delivery with measurably better fuel economy. The dream Cadillac had in 1981 fully realized nearly 4 decades later. And the really wild part? Customers don't even think about it. It's so seamless that most Silverado owners don't even know their engine is running on 2 cylinders half the time. That's how invisible the technology became once the computing power caught up. Keith Hampton, Eaton's chief engineer for engine components, reflected years later that the V8-6-4 had what he diplomatically called systems issues. But he maintained, and he was right to maintain, that the Eaton deactivation hardware itself functioned as designed. The solenoids worked. The rocker arm lockout worked. The mechanical components did their job. The problem was everything surrounding them. The fuel injection couldn't selectively meter fuel. The computer couldn't process fast enough to handle real-world driving. The EGR couldn't adapt to variable exhaust flow. The subsystems weren't ready to work as an integrated whole. Each piece worked in isolation. Together, they were a disaster. The concept was fundamentally sound. The execution was a generation ahead of the available supporting technology. And there's a broader lesson the auto industry keeps relearning. Being first matters less than being ready. Cadillac rushed this technology into full production across their entire lineup because they were desperate to meet federal fuel economy mandates and avoid the gas guzzler tax. They didn't have adequate time for real-world testing at scale. They couldn't run thousands of cars through thousands of driving scenarios because the timeline wouldn't allow it. The EPA had actually refused to grant GM a special emissions waiver for the modulated displacement system, and the reason why is revealing. EPA Administrator Douglas Cossell noted that GM representatives had admitted they had no plans to use the technology in any vehicles beyond the 1981 model year. The EPA's technical staff concluded that GM's effort to actually solve the control system problems had been, in their words, somewhat limited. In other words, the regulators looked at this engine and saw exactly what it was: not a serious long-term technology program, a short-term compliance play, a one-year solution to a multi-year problem, and they were right. The V8-6-4 was always a stopgap measure, a Band-Aid on the fuel economy problem while the HT4100 finished development. Cadillac bet their customers' trust on interim technology they knew was temporary. Their customers had no idea. Today, a 1981 Cadillac with a genuinely functioning V8-6-4 system is exceptionally rare. Most had the deactivation disconnected decades ago. Many had the wire cut so long ago that subsequent owners don't even know the car was supposed to do anything other than run on 8 cylinders. The few that still operate as GM originally intended have become mechanical curiosities, conversation pieces at car shows where enthusiasts appreciate the ambition even if the result was a mess. Some dedicated owners have discovered that replacing a worn throttle position sensor and upgrading a weakened fuel pump, two parts that commonly fail with age and long-term storage, can bring the system back to surprisingly acceptable operation. Turns out, many of the running problems attributed to the computer over the years were actually caused by two $40 parts that degraded with age and neglect. The computer itself almost never fails. It just needed the right information from sensors that were quietly dying. The engine itself, that 368 cubic inch Cadillac V8, deserves a better reputation than it got. It was the last big block the company ever put in a passenger car. The final evolution of a proud engine family that stretched back through the 425, the 472, and the legendary 500 cubic inch V8 of 1970. To the indestructible TH400, to the indestructible TH400 transmission, one of the strongest automatic gearboxes ever mass-produced, and a 12-bolt rear differential, the most heavy-duty drivetrain combination in any American passenger car that year. Muscle car-era hardware yoked to a computer born a full generation too soon. So that's the V8-6-4, a brilliant idea trapped inside technology that didn't exist yet. Cadillac looked 20 years into the future and saw it with perfect clarity: cylinder deactivation, computer-controlled engine management, variable displacement on demand, digital diagnostics. They were right about all of it. Every single concept in that engine is now standard practice across the global automotive industry. They just couldn't build it, not in 1981, not with the processing power of an early pocket calculator, not with a single throttle body per bank, not with solenoids that only knew 2 positions, on and off, with nothing in between. They needed 2 more decades of semiconductor progress, 2 more decades of sensor development, 2 more decades of fuel injection refinement before the vision could match the engineering. The idea was 20 years ahead. The technology was right on time for 1981, and 1981 just wasn't ready. And there you have it, the engine that was right about everything except timing. If your old man had an '81 Cadillac, he probably has a story. And it probably involves some colorful language about what happened at highway speed. But every modern V8 that shuts down cylinders to save fuel owes a quiet debt to that flawed, frustrating, ahead-of-its-time Cadillac engine. If you've got one of these or you've wrenched on one, drop it in the comments. I want to hear it. Subscribe if you want more of this. We do these every week.